I'm Emily from TWI, and I've been the tutor for the MEDISURF experiment. I'm joined today by Shane from the experiment team. Thanks firstly for agreeing to participate in this interview. So first, would you like to introduce yourself and tell us a little bit about who you are and what you do?
So hi, thanks Emily. So I'm very happy to do the interview today. So I'm Dr. Shane Keaveney. I'm the Research and Innovation Manager at Current Precision Medical. And basically within my role, I kind of manage a lot of our research projects and then actually conduct a lot of our research with our research team as well. And one of my main focuses at the minute is additive manufacturing, which I've been working in for the last couple of years on different technologies, but currently focused on metal additive manufacturing. In terms of Current Precision, we're an FDA registered company, founded over 30 years ago, and we work within the aerospace sector originally, and now we work within the medical device sector as well. In terms of our research, we have quite a good track record, quite a good team. We're involved in a lot of European projects and nationally funded projects as well. And our goal with our research is really to innovate and develop on the technologies we're using within our manufacturing to both drive down the cost and increase our own capabilities.
Great, thanks, Shane. And obviously one of the EU projects you've been involved in is the this AMable project with us. So would you be able to explain a little bit about your product idea that you've been exploring during the MEDISURF experiment?
The main issue within metal additive is that you actually have quite a rough surface. So when you work with say selective laser sintering or electron beam melting and you have a powder bed fusion process, what happens is the powder gets melted together with the laser or electron beam and EBM case. But when you're doing that, those little powder particles end up kind of stuck onto the surface and you get quite a rough surface. In some cases, that's desirable. So in some cases, we actually design structures and like kind of foams with really rough surfaces that actually help with osseointegration, i.e. like cells of the bones growing in there and attaching for good attachment. However, in other cases, we want quite finely polished or smooth surfaces. So if we take the example of a device, say like an implant that might be going just underneath the skin, where it might contact the bone, we want a reasonable surface. It doesn't have to be particularly smooth, but where the implant contacts the skin, we need that to be quite finely polished. So the challenge is actually how to finish components selectively in the desired locations. So with our project or our product or service, the idea really was to explore what methods of finishing are out there and what new methods of finishing are out there, and to look at, can we selectively finish with different methods.
And what exactly do you think using additive manufacturing over more conventional manufacturing methods helps you achieve?
For me, I suppose I've worked in additive for 6 to 8 years and across a lot of different technologies. So if you focus on metal additive, the main advantage of metal additive is really that you can create quite intricate structures, complex structures. Like I said, in terms of medical implants, the big advantage is actually that you can do foam structures where cells can kind of get trapped in, they can integrate in and grow into, and you can get really good adhesion of like an implant into the bone. On the other side of additive, there's the patient-specific piece. So additive is quite a flexible process. So every single component that we make could be different. So for example, if we have patient-specific implants, we could use 3D scans and we can develop, or the designer can develop an implant off that, and that can be printed through our process.
And what challenges did you expect to encounter during the project, if any, and did any actually occur during your experiment?
So I suppose the biggest challenge coming into the project was actually to understand the range of finishing techniques that are out there, and to actually understand what ones might be suitable for us, what ones we should use, what ones we should explore, and if there's any we should look to kind of either trial or look to develop a bit further, investigate. So that was probably our biggest challenge, was just understanding at the start.
And which AMable services did you use during the experiment?
So yeah, there's two services, so post-processing and simulation. And pretty much so from both those services, really with the post-processing, that was actually to help us with our first challenge of understanding what's out there. And there was quite a depth of knowledge there. They're able to guide us quite well. So some of the methods we had seen before, some of the methods we hadn't heard of before, so it was quite good. And also they had quite a good idea around generally where we should go in terms of simulation of components before we print, and that one is specifically around patient specific implants. So that was interesting. We didn't really incorporate too much on the simulation side, but it was very interesting for us to explore at the start of the project and to gain a little bit of new knowledge around. So
that's great to hear. Could you also tell us a little bit about how the AMable project in general has helped you, and how you think you've benefited from the support?
Firstly, it's been fantastic. So we've really enjoyed the project. I mean, it's allowed us to trial out different finishing methods, also to run some experiments on the printing parameters themselves to look at potential influences of print parameters on surface finish and also on costs of print and time of print. So from that, we've gained quite a new knowledge of how we can achieve different finishes quite easily, different processes we can go to.
Do you see yourselves having plans to expand your use of AM in your company for other products or other services to customers?
Yeah, in terms of AM in general, we're constantly trying to grow that value stream. So basically, we're looking to expand our AM offering. And also in terms of other products within AM, from some of the other research projects we're involved in, we're very keen to focus on the process monitoring side of additive manufacturing, particularly for medical devices. And like I said, so we're working on a couple of different research projects in that area, and we'd hope over the next couple of years that we'll be involved with new products which would help to pretty much reduce the burden of process monitoring and make it easier for people that are using AM like ourselves, and to reduce the cost of goods overall. So to make medical implants kind of cheaper and easier to produce.
Great. And finally, overall, how have you found your experience with the AMable project?
Like I said, it's been fantastic. So the support we've received from yourself, from the services, from all of the kind of people that are involved has been very good. Everything about the project's been really, really good. So overall, it's been great. It's given us the opportunity to really explore this topic, to build out our knowledge, and now to start offering it to our customers and to grow our business. So yeah, it's been fantastic. I'd highly recommend it for anyone that's in additive or interested to explore a new additive product. So
great. Thanks for agreeing to do the interview and joining me today. And obviously, good luck for yourself in the future.
no problem. Thank you very much.
Thank you.